Smart Probe Diagnostic Tools in addition to measuring tools can also be connected to the diagnostic program. These measuring tools and diagnostic programs form a single unit that is used as an effective and efficient troubleshooting tool to determine what steps should be taken when analyzing cell phone logic board damage. The Smart Probe Diagnostic Tools program has provided a large selection of diagnostic guides for various cases in the field. To start using software diagnostic tools, you just need to adjust the brand, type the phone and then determine the type of problem you are facing. Through this diagnostic software you will be guided in the steps of the analysis. This is a list of the steps you must take. After you take measurements on each of these lists, this software diagnostic tool will automatically tell the results, whether the value is suitable or not. For every measurement you will make, this software will provide detailed information about the series to be analyzed. And when you have taken measurements, this software will automatically notify the components that have the potential problems. You can look at the illustration display of this connector to find out the status and condition of the measurement results. Green cursor is a sign where you have to do the measurement. The gray pin is the pin that you need to measure. Green, a pin that has been measured and declared no problem. If it is blue, the pin has been measured but is declared open circuit or broken line. While the red is a pin that has been measured, but in the path there are short components. You can see the layout of this board to see the position of its components, and will automatically zoom in and mark the position of the component or its path. How does this smart probe work? Data diagnostic information tools are stored in a database server. This is to facilitate our team to update or add new types and cases. This diagnostic tool software can provide information on the condition of a circuit or component that is potentially problematic, by making a comparison between the ideal value and the actual value. This ideal value is the value we have gotten from a normal cell phone, and we have stored all of these values in a database server. So, with this Smart Probe diagnostic tool, you don't need a machine or logic board as a comparison material. This ideal value will be compared with the actual value. This is the measurement results contained in the logic board that we are analyzing, then with the results of the comparison between the ideal value and the actual value. When a difference occurs outside the tolerance limit, then this software will automatically indicate the location of the problem or potential damage. Logic board problems can be caused by many factors, from mild to severe. This is due to the structure of the circuit is very complex and involves many components located in a particular block or area. It will be very complicated to process of analyzing this logic board. But to simplify it, this diagnostic tool has 4 levels of analysis, so that the problem can be localized properly, having contents that will guide to step-by-step troubleshooting. At level 1, the area analyzed is generally for user interface problems. Troubleshooting this method to ensure that the circuit components in the connector area leading to the CPU or SoC are properly connected or not. This method can help you to determine the damage caused by several components including ESD diode, filter capacitors, or determine if there is some disturbance or block in the path. In this Level 1 method, you will be guided to measure on the connector pin using the drop-down voltage mode, or commonly called as diode mode. This method of measuring the logic board is not in active condition or power off, because the direct voltage applied from the probe is 3 volt. This voltage provides forward or reverse current on the CPU path to the connector. So when the drop-down voltage does not match the ideal value, we will be able to find out which component has the problem. Now I proceed to the troubleshooting method at Level 2. Troubleshooting in this area is continued after Level 1, where the previous analysis measured was only in the area of the connector to the IC. Therefore the analysis cannot yet be stated complete. Because the measurement method is not included passive component area needed on the IC support, then you need to proceed to troubleshooting Level 2. This is done to ensure the series of components needed for the IC to function properly. We need to ensure if there is a passive component that is damaged, for example, capacitors, inductor, filter, diode, resistor, etc. The troubleshooting method for this measurement is exactly the same as what was done at Level 1, using the passive logic board, and the measurement using the drop-down voltage or diode mode method. By doing this measurement, the voltage from the 3 volt will flow the voltage into the measured circuit. When there are passive components with problems, this will show where the damage is located. An indication of the results of this measurement can also be used as a benchmark if there is a pin out, IC is broken, or corrosion is present in the area under the IC. And of course, if it is confirmed that the pin is out and the BGA section are not problematic, we can sentence the IC that has a problem. At Level 3, troubleshooting in this area will be done when troubleshooting Level 1 and Level 2 has passed. That is, it can be confirmed that the circuit area is not problematic. Therefore, you need to proceed to troubleshooting the working voltage area. This problem could be due to the problem IC. It could be from the LDO IC, low dropout, or it might be from the PMU that has the problem. In this Level 3 method, in contrast to the Level 1 and 2 method, measuring with the condition of his cell phone is passive. However, in this Level 3 measurement, the logic board must be in an active condition or powered on, because what you will do is to ensure the working voltage generated from the IC regulator such as LDO, SMPS, PMU is appropriate or not. Now I continue to explain the Level 4 analysis method. Level 4 is different from Level 1 to 2 and 3, where in Level 1, 2, 3, analysis is done from the PCB or logic board. While in this Level 4 what we analyze is the condition of the IC pins. So at Level 4, this IC must be in a condition separated from the logic board. Then with this smart probe we do measurements directly to the IC pins. Well, in this particular case it only uses the diode mode method. So the analysis is done by doing forward and reverse bias. Meaning here the accuracy cannot be confirmed a 100% accuracy if the IC condition is good or not, but at least by doing forward and reverse bias voltage injected from SmartProbe with diode mode method, we can assume the condition of the IC is feasible to use or not.